Okay guys, this is the section 1.7 for Pre-Calc. There's a lot of fancy terminology here guys, functions and models and formulas and graphs and all this other stuff. But really the bottom line here guys is we're going to take some different formulas, solve them for different variables in that formula, and then we're going to do some word problems, have some different situations, and be able to come up with an equation for that problem and then solve that equation and find out what the problem's asking us for. So first, we're going to talk about area of a circle. Okay, they want us to write the area A of a circle as a function of its radius. Now really all this is that area equals pi r squared. So when they ask write the area A as a function of the radius, they're just saying, hey, give us the formula. Tell us what it is. Okay, here it is. A equals pi r squared. Now, as the diameter, now we have to write the area as a function of the diameter. Now, obviously there's no diameter in this formula. Okay, but think about what radius is. Radius is half the diameter. Okay, so instead of r, put 1/2 d. Okay, same formula, but the radius is half the diameter. Well, that's a good way to get d into the equation, right? So let's simplify this. So I have pi times 1/2 squared is 1/4, d squared is just d. Now if I clean that up a little more, pi times 1/4 is just pi over 4, d squared. So that would be my formula for the area of a circle as a function of its diameter. Okay. Now, when we talk about circumference, okay, when we talk about circumference, now the formula for circumference is c equals 2 pi r. So really what I'd like to do, if possible, is I'd like to be able to solve the circumference formula for r and then plug it in back up here. So the first thing I'm going to do is I'm going to divide both sides of the circumference formula by 2 pi. So c over 2 pi is the radius. Okay, so I use circumference, the formula, to get r. Now, I'm going to take that and I'm going to plug it in for r. Okay. Now, we got a lot of work to do here. Okay. Couple things. I'm going to erase some of this because I need more room. Okay. If I square that fraction, I get pi times c squared over 4 pi squared. Okay. So I just took and I just squared everything in that fraction. All right. Now, if I multiplied the pi times the top, I would get pi c squared over 4 pi squared. Now think about how you can reduce that, guys. You have a pi on top and a pi squared on the bottom. So I can reduce out one of the pi's. So my final answer for part C, the formula for area of a circle as a function of its circumference is A equals c squared over 4 pi. Okay. So just a quick recap. And by the way, guys, this video is going to be somewhat lengthy, so hang in there. We use the circumference formula to get... Oh, it paused on me. Anyway, sorry about that. We used the circumference formula to find r. Once we got that, we plugged it in to the area formula for r, and then we simplified from there. Okay? All right, now, here starts the word problems. Okay, you've got a square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard, and the sides are folded up to form an open-topped box. Okay? So, what they're saying is that square got cut out, and it got cut out here, and it got cut out here, and it got cut out here. Okay? So then they took each of the sides and they folded them up, and now you've got a box. Okay? Now, the one thing I want to think about before I start worrying about formulas and all that stuff, okay? What is, well, let's look at volume. Volume is what? Length times width times height. So what is the length of this? Okay? What is the width? What is the height? Okay? Well, I don't know the dimensions of these squares. I don't. So what I have to do is, I've kind of got a, well, it's a square, so all four sides are the same. I don't know what the sides are. So every side is x. Let me fill those in. Okay. Now it's 8 by 15. All right? So if this right here, whole thing is 15, right here, well, this right here is how long the actual box is. The cardboard is 15 inches long. The box is not 15 inches long because I cut out these squares. Well, each square has a length of x. So if I wanted to find the length of what was left, okay, it would be 15 minus 2x. Because two of the squares got cut out. Now, think about it. You think you'd do the same thing for the 8 inches? Of course you would. So, again, if this whole thing is 15, let me clean this up, guys, because that's really messy. Okay? Let me clean that up. So if that's x, and this whole thing was 15, the length from here to here would be 15 minus the two x's that I cut out. Now the same thing happens here. If the whole width of the cardboard was 8 and I cut out two of the x's, that means that my width is 8 minus 2x. Now, the height of it, the height of that box, okay, you could call it depth because that's how deep the box is. The depth is just x because each side of this square that we cut out is x. So when you cut it out, that length, when you fold it up, when you fold up that side, okay, it's going to be x units tall, okay, or x inches tall, I should say. All right, so I've got length, width, and height. All right, so my formula is going to be, now, does it matter what order you multiply those in? No, it doesn't, okay? So if you did length times width times height, that's fine. But if it looks a little bit better if you just do it this way. Okay? So, again, let me clean this up, guys. I know this is real messy, but I'm just trying to show you the diagrams are a little small, so I want to make sure that you guys kind of see what's going on. All right? So here is our volume. Okay? Now it says find the domain of V as a function of x. Now it says, note that the model imposes restrictions on x. Now some of you might say, well, Mr. Habit, the domain is all real numbers because there's no fractions, there's no square roots, we're fine. And in a normal situation, we would be. The problem is we are dealing with the dimensions of a box. So think about this. Can x ever be negative? And the answer is no. Okay? You can't have a negative length. You can't have a negative width. You can't have a negative height. Okay? Now, can you use 0? Okay? Can you use 0? Well, if I use 0, what happens? That's 0. So 0 times everything is 0. Well, can you have a function or can you have a box that has a volume of 0? I guess. I mean, you wouldn't have a box, but you'd have probably the smallest box of all time. Well, what are the other restrictions? Okay? What are the other restrictions? Can x be bigger than 4? Think about this factor. Okay? If x is bigger than 4, this whole thing becomes negative. That's bad news. Okay? That's bad news. All right? So the height has to be positive. The length, or the width has to be positive. So our domain is only from 0 to 4. That's it. Okay? Because anything bigger than 4 is going to make this negative, which is bad. Now, we don't have to worry about that. Okay? We don't have to worry about that in the domain, because 0 to 4 will work for all three factors. Okay? 0 to 4 will work for all three. So some of you might say, well, why won't you just take 15 minus 2x and just set that equal to 0? Well, you could. Yeah, you get 7.5. The problem is that any numbers bigger than 4 for this one make it bad. So it doesn't matter what this is, because 7.5 is great, but everything from 4 to 7.5 is bad. So you got to stick with this. Okay? Now it says graph V as a function of x over the domain found in part B, and use the maximum finder on your graphing calculator to determine the maximum volume such a box can hold. So what you're going to do is you're going to graph. So you probably should have your calculators available to you. You are going to graph that. And as a matter of fact, I am going to do the same. Now, you can't see me, John Cena. But, again, hopefully you hear my calculator buttons clicking like crazy. So I'm going to graph it. I'm going to graph the volume function. Okay? And I hit enter, or I hit graph. And that's insane. That really looks okay. So I'm looking at my calculator, and you're probably looking at your calculator, and you're going, oh my God, Mr. Habit, what do I do? Well, this is what you do. Set x min equal to 0, x max equal to 4, y min to 0, and y max to good old 100. So go to Window, x min 0, x max 4. My calculator shut off for some reason. This is how teaching goes, everybody. Sometimes you just fly by the seat of your pants. My calculator just randomly shut off. Alright, so my window, x min is 0, x max is 4, scale's 1, that's fine. The y min is 0, and then the y max is 100. My y scale should probably be by like tens or something, because I'm not sure I want 100s or ones going up and down the y-axis. That's a lot. So I graph it. Okay, you should get some sort of weird looking curve. It kind of looks like a parabola, but it's sort of like a mutant parabola. Okay, it's sort of a hanging to the left parabola. Okay, now what we want to do is, okay, we want to find the max. We want to find the top of where that curve is. So we use the max function. So we go second trace. Okay, second trace. Then we want option 4. That's maximum. Okay. Set the left bound. Well, let's put it all into 1. Set the left and right bounds. So let's do that. So I'm doing that. You can't see me do it, but I'm doing it. Oh. My calculator just shut off again, randomly. Awesome. Well, anyway, the maximum point, this is crazy. This is maybe the craziest video I've ever done in my life. Okay, so the maximum, okay, is at 1.67, 90.74. Okay, that's where the max is. Okay, now that means this. Okay, that means, oh boy, I'm out of room. That means that the max volume is 90.74 inches. Is that correct? Inches cubed. So in other words, the max volume is whatever the y coordinate of the maximum point is. Now, when it says how big should the cutout squares be in order to produce the box of maximum volume, okay, well, that's just the x coordinate. So each square should have 1.67 inch sides. Okay? So use your calculator to find the max. So graph it, find the max. Okay? You might have to play with your window, guys, a little bit, like we had to there. All right, if you graph this function on a standard window, it's going to look crazy. So you got to play with it. Okay? Find your maximum point. Your y coordinate is the maximum volume. Your x coordinate is your length of the sides of the squares that you're cutting out. Okay? That's a lot. That's a lot to kind of take in. Okay? We're actually going to stop here for the moment. All right? I just want you to take in the first two examples we did. We're going to go over some stuff, on the worksheet just up to that point. And then what I'll do is I'll make a video for part 2. And I'll do the rest of the examples, and then we can do the rest of the problems, because I don't want you to get overloaded with information. So hopefully you got something out of that, because I certainly did. Calculators are crazy, and there's not a lot of room on this iPad, and hopefully you're able to understand some of the stuff. If you don't, we can always go over and talk about it in class. All right?